So in section 9.3, we were learning about graphing rational functions. So there was a whole list of things we went through. The first thing we needed to do was find the x-intercept, y-intercept, vertical asymptote, horizontal asymptote, slant if there were any, and then we sketched the graph. All right, what I'm telling you for your homework, which is very, very important, is that on these problems, always factor the numerator and denominator first, because you might also have a hole that you need to draw. Okay, so always factor first. So always factor first to find any holes. Okay, so when I factored the numerator, it was x squared minus 4, so it's now going to be x plus 2 times x minus 2. And my denominator is going to be x plus 2 times x plus 3. So what does this tell us? Yep, since those cross out, if you plug negative 2 in for x, you would have gotten 0 over 0. So this means that there's a hole at x equals negative 2. Okay, so what we're graphing is this new function, x minus 2 over x plus 3. That's what we're going to find the vertical asymptotes for, the horizontal, and so on. So graph this. Okay, so you don't want to make it so hard on yourself where you have a vertical asymptote at negative 2, because it's not actually at negative 2, there's just a hole there. Okay, so graph the new one. Okay, so let's find the x-intercepts and y-intercepts first. Okay, x-intercept, you plug in 0 for y, so I have 0 equals x minus 2 over x plus 3. Okay, remember last time we talked about you can't have a fraction equaling 0 unless your numerator was equal to 0, right? So you're really only worried about things like 0 over 5 or 0 over whatever. So the denominator doesn't actually even matter. So this x plus 3 doesn't even matter. And I told you guys, a lot of my students like to think of just multiplying it over and getting rid of it. You can do that if you want. Okay, so I have 0 equals x minus 2, which gives x equals 2. That's my x-intercept. My y-intercept, plug in 0 for x. So in this new function, I have 0 minus 2 over 0 plus 3. So I get negative 2/3. Okay, vertical asymptote. Do you guys remember what we do to find the vertical asymptote? Denominator equal to 0. So set your denominator equal to 0. So you get x equals negative 3. That's a vertical line. Horizontal asymptote. Do you guys remember that one? No, not numerator. There's a shortcut. Remember, there's a shortcut. All right, so if you look at your degrees, this was x to the first power and x to the first power. So that's my largest degree. Look at the numbers in front. They're both 1. 1x over 1x. So it's going to be just 1. So 1 over 1, which is 1. All right, so we're going to put all this together. So at negative 3, I have a vertical asymptote, so a dotted line that I'm not going to cross. At y equals 1, I have a horizontal asymptote. That one I don't cross on the ends, but you could sometimes cross in the middle on these. I have a y-intercept of negative 2/3. That's almost at negative 1. And I have an x-intercept of 2. Okay. If you get confused, you can always do more points. But what I see is that I'm going to go along the horizontal asymptote. It doesn't touch. Mine looks like it touches, but it just goes right along it. And I'm going to hit that y-intercept, and then I'm going to go along the vertical asymptote. So you're going to have that little curve in there. Okay, same thing over here. Now, I'm either going to go, so do you guys see these lines? I'm either going to go like this, or I'm going to go like that. But I don't know which one, so we got to figure out what we're going to do. Oh. I didn't know I could write on there. There we go. All right, so we got to figure out if we're going to be above or below. So what do I need to do? Yeah, do one more point. What's a good point to try? Nope, we want x equals -4. Do you guys see? Because this was -1, -2, -3, -4. So we want to see what happens on that other side of the green line. So plug in -4 into your new function. So I'd have -4 minus 2 over -4 plus 3. So it ends up being -6 over -1, which is just 6. So that means it's way up here. So you can go up to 6 if you want. 1, 2, 3, 4, 5, 6. So that's how I knew that it's going to be above, so it's going to fit within those asymptotes like that. So that's what your graph looks like. Okay. Last thing, you had a hole at -2. So don't forget that you had taken that hole out from before. So right here you have a hole from this. Because in our original function, if you try to plug in -2, you get 0 over 0, which is undefined. So you shouldn't have a point at -2 at all. It should just be undefined. So since we had crossed out, see in the red marks, we crossed out x plus 2 over x plus 2, that gave us a hole at -2. Yeah, Jasmine?
What happens if your x-intercept is like y, 0 equals 3?
Oh, then that means you don't have an x-intercept. So maybe that in that case there would be some kind of like asymptote, like a horizontal asymptote on the axis.
Okay.
So you wouldn't ever cross that line. Do you see what Jasmine's asking? She said she tried to solve one of these and she got 0 equals 3 to be a x-intercept. Well, 0 doesn't equal 3. That's not defined. There's no solution there. So that just means it's not crossing this axis here. It doesn't cross at all. Okay, I'll do one from your homework. So hopefully you guys did it, so you can ask me questions. Okay, Abby, what's your question about that first?
How did you get 6 -4?
Oh, because I plugged in -4 into a t-table. And I plugged it in to this function right here, Abby. Do you see it up there? Okay. Lily or Carolyn, I heard you guys say something?
Oh, this is no.
No?
Okay.
Okay, so what one do you want me to do from homework?
Yeah, do
Number 1? Okay.
Yeah, so you have to add that.
Okay, here you go, Michael. All right, so always factor first. So I'm doing number 1. So always factor first. So in this case, I have 3 over x minus 2 times x minus 2. It's easy to see there aren't any holes on this one because I didn't have an x minus 2 on the top and the bottom. So this is the function we're graphing. It didn't simplify. So let's start with the x-intercept. So my x-intercept set 0 equal to your y value. So f of x. So this is what Jasmine was asking about. You get 0 equals 3. That doesn't work, so there's none. There's no x-intercepts. Y-intercept, set x equal to 0. So everywhere you have an x, put 0 in its place. So I have 0 minus 2 times 0 minus 2. So I get 3 over 4, so 3/4. Vertical asymptote. Set your denominator equal to 0, so x minus 2 equals 0, so it's at x equals 2. Horizontal. So looking at your original, what is your largest degree? X squared is your largest degree, right, 2? So there were no x squareds on top. So I have 0x squared over 1x squared. So it's y equals 0 over 1, which is 0. So y equals 0. Are there any slant asymptotes? No, there's only a slant when the degree of the numerator is exactly 1 more than the degree of denominator. So if I had x cubed on top, then there would be. All right, sketch it out. When the degree of the numerator is exactly 1 more than the degree of the denominator. So see how this was x squared on the bottom here? So if you had something x cubed on top, if that was the degree on top. Nope. If you just had x, then it's 1 degree less. You want it to be exactly 1 degree more. What do you mean? Like if you had just a number on the bottom and you had an x on top? Yeah. X squared and 3x or something like that, then you would. All right, so here we go. So at x equals 2, I have a horizontal asymptote, or a vertical asymptote, I mean. I have a horizontal asymptote at y equals 0. That's why there was no x-intercept. Okay, y-intercept at 3/4, so almost at 1, but not quite. So based on that 1 point, I know it's going to go along the horizontal, it's going to go along the vertical, it's going to look like that. What other point do I need to plug in? Can't plug in 2, that's where the asymptote was. Positive 3? Yeah, let's plug in 3. So I get 3 divided by, you can plug it into this factored form here. So 3 minus 2 times 3 minus 2. That's a minus sign. So I get 3 over 1 times 1, so just 3. So I'm at 3, 3, right up here. So it comes down, goes along the asymptote like that. There were no holes, so that's the end of it. If something on the top factored with something on the bottom, like x minus 3 and or x minus 2 and x minus 2 were both on top and bottom. Okay, moving on. So let me save this as.
Can you have 2 vertical